This video will explain how to get to know your data as an initial check once you have imported the data. There are several things you can do. First, examine the raw data in a spreadsheet viewer using the view function. So we have this data set that we imported into RStudio, and now we will use the view function that opens the average age of dollar billionaires years data frame in the data viewer. So we can see many zeros, countries, and also other than zero numbers. Next, we will apply names function that lists all the variable names to list all the variable names in the data set. So once we apply this function, we can see the names of all the variables. So there are 5 variables in total. The first variable's name is country. The second variable's name is 2004. The third variable's name is 2005. The fourth variable's name is 2006. And the last variable's name is 2007. And we will use summary function to look at the descriptive statistics for all the variables. And here, in this output, you can see that this the first variable, which is called country, it's a character variable, and the other 4 variables are numeric variables, and whose minimum first quartile or 25th percentile, median, mean, third quartile or 75th percentile, maximum, and maximum values, minimum, first, median, mean, third quartile, maximum values are listed. Now you may also apply the asTable function from the tibble package, which is part of the tdiverse collection. And if you have already downloaded tdiverse package, then you just need to load the tibble package by using the library function. And this function allows you to see different pieces of information in your data set. Dimensions of the data set, such as number of rows and columns, variable names, variable types, first few lines of raw data, since the tibble package is part of the tdiverse. And as I already mentioned, you don't need to install it if you already install it, and just need to load it with the library function. So then, to look at the data set information, we will run this line of code. And as shown in the output, the data set has 194 rows and 5 columns. And below each variable name is the variable type, so a character, or DBL, which stands for double precision floating point number, and the first 10 rows of data. While these initial inspections, by looking at the descriptive statistics and at the first 10 rows of data, reveals 2 unusual issues with the data set. First, the variable names, 2004, 2005, etc., may be somewhat difficult to interpret. Now, for example, the meaning of 2004 is not quite self-evident. And even though we could assume that this stands for the average age of dollar billionaires in 2004. However, perhaps, and as it will be shown later, we can have a more meaningful name for these numeric for variables. Second, you can see that many countries have zeros for the average age of billionaires. And it is more likely that those zeros refer to missing values rather than zero in age. One indication that this is the case is because, as shown by the summary function output here, the median billionaire age is 0. And the average age is around maybe 13, 15, so on. Something is definitely wrong. So to use the data properly, you might want to address these two issues first. So how do you rename these variables? Well, we can change a variable name by applying the function rename from the dplyr package. And inside the rename function, first we will list the variable name, followed by the equality sign and the old variable name, as you can see in this line of code. So we have here multiple variables that we would like to rename, and they are included one by one, right? So we'd like to rename variable, which is called 2004 in the original data set, as avh 2004, and so forth for each of these numeric variables. Now, also what you see that first we need to, before running this line of code, we need to load the dplyr and magrittr packages. And then we also would like to, in order to use magrittr, to use the pipe operator, and dplyr package to use the rename function, which is part of the dplyr package. Now, the output of the rename function is assigned to the original data set. So you see the same name of the data set is listed here. This is the name of the output data set, and we use the assignment sign, to do this. So now we can run these lines of code. And what will happen is that here you can see that the names of all numeric variables were changed from just 2004, 2005, 2006, 2007 to FH 2004, FH 2005, FH 2006, FH 2007. Now you can use the following code to show you the new variable names in the data set. So we will just double check the new variable names by using this line of code. And we see that all the variable names here are also listed, and you can also check how these variable names are changed in here. How do you deal with the missing values? So that was the second issue, right? Because of the missing values that were specified as zeros instead of NA, we had some strange descriptive statistics with the average age of billionaires around 13, 15, 16 years. So again, R only recognizes NA as missing value. So for observations that have no valid value but zero only, R actually treats zero as valid value. So you need to record the zero values as NA using either recode function, which we discussed in one of the previous videos in this series, or the NA if function. Let me show you this function to you as well and how it works. To replace zero values with NA. So in the NA function, first we list the data frame or variable whose certain values need to be converted to NA, and this followed by comma, and the value of string, in this case 0, that needs to be converted. So let's run this line of code. And after running the code, let's check the data using the view function. The as table function and the summary function. So first we will use view function. So we can just take it from here, copy it, and paste it here. And run this line. And so we see now all zeros were changed to NA, which looks quite good. And we can use as table function as sort of a double checking, and also see it that yes, we have again those 194 variables, right? Nothing changed. 194 observations, sorry. 5 variables. We have the same type of the variables, right, as before. And now we can see the first 10 observations, and we see that all those zeros for those 10 observations were changed to NA. Now let's run and let's look at the descriptive statistics. So once we run this and look at the output shows that none of the average age variables has 0 values anymore, right? So we see that mean values are 64, 63.11, 61.38, 61.4. And each of them now has the number of NA listed in the summary function output, and also how many NAs we have, right, for each of the 4 years, this data set. Interestingly, billionaires got younger from 2004 to 2007, right, around the world. And you can see this pattern from a variety of statistics computed here by the summary function, such as minimum age and median age, and then also the average age. In addition, these values certainly are much more reasonable than those, these variables are much more reasonable than those produced earlier when 0 values were not treated as missing values.